Hello, I'm going to try to explain with a little more detail the sample that we have in the slides. Let's go to it. We have these relations that are the roots, the climbers, and the climbs that these climbers have been climbing. It's interesting to view that in climbs we have the climber ID and the root ID that make the relationship between both tables, and in climbers we have the climber name. That is something that we are going to need in the exercise. Let's start with the question. We need to find the names of the climbers who have climbed a certain route only one time, no more than one time. How we can do that? Well, this is what you need to do in almost every problem that you are going to have in the assignment. You need to divide and we find smaller things that you need to do, and with these solutions create the big solution. Let's explain this. In this case, we can find very easily all the climbers that sometime have climbed any mountain. And we can find, this is a little more complex, but we can do it, all the climbers that have climbed 2 times or more. So if we pick this first list with all the climbers that have climbed at least one time, and we remove from that big set the list of all climbers that have climbed the same route at least twice, we're going to keep only the ones that have climbed a certain route one time. Let's go to view this. Let's start with the first part. We need to find the names of climbers who have climbed some route at least once. Here we have the table, the relationship, the relation climbs. And we need all the climbers IDs that are in this table. To do this, we need, this is what was in the slides, we need to create a relation called AO, and we are going to make a projection in the table climbs with the climber ID. This is the same using the rename raw formula that rename to AO this relation that is here, that is the projection of climber ID and climbs. These both are equivalent and it's the same. And what is this doing? Well, we're going to keep only this column and we're going to remove the others. And at the same time, we're going to change the name to AO here. So this is the magic. If we do this, we're going to have AO and keep the climber's ID. Once we have the climber's ID, this is enough for the big problem that if you remember, we were going to do A0 minus 80, but we want to find the names. So let's continue a little more. To define the names, we need to pick A0, we need to go to the table climbers, and we need to select the name and maybe other things from this table, from every one that is in A0. This is done with the natural join. This has the same name, CID has the same name in both places, so we're going to do this natural join. Again, this thing is the same that this rename of this equivalent. So with the first 1, 1, 2, 3, we have this, 3, 1, 3, we have this, 2, 1, 4, we have this other, and this one is not in this list, so this is going to disappear from this natural join. And the result is the relation R with these 3 rows. If we continue with the exercise, the final result is only the name. We don't care about the skills or the age. So we are going to make a simple projection. Again, this is the equivalent. Simple projection. We are going to call it rows. And this is the result of the first part of the exercise. Remember that we don't need this. We need the A0 that we find before. A0 is the projection, and we have these 2 steps more to find the name. Let's go with the second part. We need to find the names of the climbers that have climbed the same route at least twice. Well, if we need to find the same route at least twice, we're going to need to have twice the table climbs. We can do a product, a join between them. And the problem is that, well, the first one is called climbs and the second part of the join is going to be called climbs. So let's rename it. And we are going to do this. This one, rename it, join it with climbs. Why? Because if we do this, we're going to have this result where we can differentiate between R1 RID and climbs RID. If we don't rename this one, both are going to be called climbs RID, and we are not going to be able to know what column we are talking about. Really, we cannot do that, but it's just for the example. We need to rename. And if we return to the solution that we have in the slides, R2 is going to be R1, theta join, and these conditions here. So let's try to understand what is going to do this theta join. Theta join is the same that make a normal join and filter, select later with this condition. Let's explain this condition. We have R1, CID, climber ID, and climbs, climber ID. Both needs to be the same. Yes, because we are searching for a climber that is in this side and in this side at the same time. Again, the route is going to be the same too. We need climbers that have climbed the same route at least twice. And how are we going to differentiate between the situation where this join is joining a record with himself and their date is the same? We need that both dates are different. With this, we're going to have a climber in the same climb, but in different days. So we have at least twice. Let's try to find the climbers that we have. If we start, this first record is the join with himself, so the date is the same. But if we go to the second, we have 1, 2, 3, 1. Here we have the same 1, 2, 3, 1, and the date is different. So this is going to be one of the selected ones. If we continue, we can view that 3, 1, 3 is different than 1, 2, 3. I don't need to view everything. We continue, we view that 1, 2, 3, 1, one date, 1, 2, 3, 1, a different date. Well, this is the same that this, but in other order. We are going to talk about this later. If we continue, we can find that near the end, we're going to have 3, 1, 3, 1, and this date, 3, 1, 3, 1, and this date. So this is the same, but if we go a little down, we have this with a different date. So this is going to be selected. And if we pass to the next page, where is the rest of the table, we can find the other part of this. Again, we're going to filter and only keep this. So let's do it. And you can view that we have kept 4 records. As said, we have twice this person because here this is the same that this, but in other order. This is important, and there is a sample about this and a question. If we instead using different, okay, I forgot one thing. We're doing the theta join. That means that the columns that have the same name, and we have been using here with the equals to join, are going to be merged. If you look at these columns, they have the same value, both. So we can remove and keep this. Okay, I was talking about the different that is giving us 4 different values when we really need only 2. If we change to minus, instead different, we're going to select from these two the one that the date is minor than the second date. So 87 is minor than 88. And the same happens in this situation. 89 is minor than 94, and this other with 94, 89, we are going to remove it. And we will only keep these two records. If in some exercise they are asking for don't have duplicates in this way, you need to remember to use minor less than instead different. Let's pass to the next part. Once we have this table R2, the solution that we have in the slide says that we are going to rename it to 80 and we're going to keep only the CID because we don't need all the other things. We are just searching for the names of the climbers, so we don't need any other information. So doing this is going to filter, change the name to 80 and keep this information. Now we have A0 and 80, but let's finish this exercise again, making the natural join between climbers on 80 and keeping only the two that are climbing the same route twice. This exercise says that we need to keep only the name and rename R3. We do that, and this is the result. Now, we have A0 in the first exercise, 80 in the second one in an intermediate step, 80 here. Okay, let's view how to find the names of the ones that have only climbed exactly once a certain route. Remember this diagram, we are going to do this operation, A0 minus 80. This is A0, this is 80, and the minus is used, pick one from here and remove from here. This one is the same, so we don't do anything. And this other, we are going to remove this and this. And the only one that remains is the 214. Here it is. A0 is going to be the climber ID 240. As they are asking for the names, we need to do the same that we did before. Natural join. CID is the same attribute, the same column name than here. So we are going to filter only by this and join both tables and remove everything that we don't need and just keep Arnold. And the last step is remove the column, the other columns, and keep only C name. Here we have C name and Arnold. And this is the result of the big problem.